One of the dangers of business data analysis is making decisions too soon. The reason is that short-term results can be deceiving, but you should start to see patterns as you gather more data. One reliable principle of data analysis is the central limit theorem, which says that as the number of measurements increases, the more likely it is that your data will be distributed as you expect. As an example, let's say that your data is normally distributed, and a normal distribution has an average and also a standard deviation. In this case, we're looking at a so-called normal curve with a mu, or average value, of 100 and a standard deviation of 20. And you can see a curve of values on this graph. And on the left, in the vertical axis, there is the probability of a specific value occurring. So you can see that the chance of getting exactly 100 is 2%. That's pretty low, but there are a lot of values clustered around it. And that is where the power of the normal curve and normal distribution comes into play. If your data is normally distributed, and a lot of it is, then you should expect to see about 68% of your values in your data set within one standard deviation plus or minus of the mean. In this case, that would mean that 68% of your values would be between 80 and 120. So again, that's the average or mean of 100 minus 20 for 80 and plus 20 for 120. You can also expect to see about 95% of your values within two standard deviations plus or minus between 60 and 140, and approximately 99.7% of values within three standard deviations plus or minus. And of course, the probabilities of seeing other values get smaller as you go further away from the average. It doesn't mean they never occur, but it does mean that they are very rare. To show you how this data works in practice, I will switch to an Excel workbook, which you can find in the exercise files collection, to use a macro to generate random values and show you what it looks like in practice. The workbook I'm using is 0104 Central Limit Theorem, and as I said, it is available in the exercise files collection. This workbook uses macros, so I'm going to go ahead and enable that content. If you're not able to run macros on your own system, then you probably won't be able to interact with this workbook. But if you can, go ahead and click Enable Content, and we're ready to go. So what just happened was that Excel recalculated my workbook, and I have a new set of random values. I have 30 values, and again, it's within plus or minus 3 standard deviations from the mean. Currently, I have 30 values selected, and if I click the 30 button, and you'll see that I have 4 values that are 1 standard deviation above the mean, and I have 1 that is 3 standard deviations below, and so on. But also note that the values are distributed in what appears to be a flat pattern. You don't see the curve that we saw in the graphic earlier. Now let's go up to 100 values. So I'll click 100. And you can see we're starting to get something that looks a little bit more like our curve. We're seeing more clustering toward the middle. So I'll click 100 again, 100 again, and we're seeing patterns, but it's not what we looked at before. So now I'll click 1,000, and here the pattern really does start to develop because we have created or randomized more values, and we're seeing a bit more of a hump in the middle. And if I click there again, and you can see that the pattern is much more like what we expected. Now I'll click 10,000, and here the curve really starts to look like what we saw in the graphic earlier. So you have 10,000, and it's still a little bit lumpy in the sense that some bars are larger than others toward the middle, but it looks very much like the curve we saw. And finally, if I click 100,000, then the curve looks almost perfect. Because we're taking so many values, we've had the opportunity to smooth out random chance, and our values look very much like the normal curve that we saw before. So keep measuring, keep analyzing, and keep an open mind as to what your data tells you.